Hello viewers, in this video let's learn about recursion. Any function that calls itself is said to be a recursive function. Recursive function has two cases, recursive case and a base case. Base case is also referred to as a stopping point. The case in which the function calls itself to perform a subtask is called a recursive case. The case in which the function doesn't recurse is the base case. Every case must eventually lead to a base case stopping point. A problem solved by recursion can also be solved by iterative approach. Iterative solutions are usually more efficient than recursive functions. This is due to call overhead for function calls on most platforms. Simple examples of recursion functions are printing the factorial of a number and printing Fibonacci series. Let's take the example of factorial and look at the program in order to understand recursion better. So here is the function of factorial of integer n, and then this is a recursive function because it calls itself here, where ival when n is greater than 0, ival is equal to n multiplied by function factorial of n minus 1. Here this function calls itself. When n is greater than 0, this is the recursive case. So when n is greater than 0, the function is going to call itself. When n is equal to 0, it goes to the base case, which is ival equal to 1. So eventually this recursive case, every case ends with the base case. So here if we do want to find out the factorial of 2, we pass factorial of 2 and then it says 2 multiplied by factorial of 1, and then the factorial of 1 is calculated as factorial of 1 multiplied by factorial of 0. Factorial of 0 is the base case, which is the stopping point, where factorial of 0 is set as 1 in the base case. So that way we get 2 multiplied by 1 multiplied by 1, which is 2. Factorial of 2 is 2. That is correct. So now let's try and find out if this recursive function works. Let's find out the factorial of 4. Factorial of 4 is 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. So let's execute and see if this gives us 24. Yes, it does. Now let's look at the iterative approach. We have said that the problem solved by recursion can also be solved by iteration. So let's look at the iterative approach. In this iterative approach, what we do is the function does not call itself. In iterative approach, we use a loop and then we loop across all the values from 1 through n, which is the number that you pass, and you multiply all the numbers from 1 through n, and that gives you the factorial of the number. So here that is what this loop is doing, and then it iterates from 1 through n and then gives you the factorial of n as ival, which is this, where it stores the factorial of the number. So if you are trying to find out the factorial of 2, so it says 1, I is equal to 1, then it goes to I is equal to 2 and stops there. So 1 multiplied by 2 is 2, and then you get the factorial of 2 is 2. So here let's try out the same thing. Since we tried out 4, let's try out 4 here again and see if it gives us the result as 24 for the factorial of 4. Yes, factorial of 4 is 24. There you go. I hope this is clear. Recursive functions can also be implemented iteratively. I hope you understand what is a recursive function, what is an iterative function, what is an iterative approach, and how we can solve problems using both the approaches. Thank you.